So today we're doing a very, very brief overview of the acid and base equilibrium. Yeah, very advanced A-level topic. Paper 1, paper 3 can come up, very experimental and extensive calculations. So I'm going to go through it very, very briefly. So again, I'm going to do it for all of exam boards, okay, because this is one of the topics that is the most similar, and we're going to look at the key concepts. Okay, I'm going to skip the definitions, the equations, because I hope that at this point you're quite confident with. Conjugate acid base pair is something that we're going to revise better in exam practice. And again, I want to explain this topic in a very clear way, which is there are only a few types of calculations that you can do. And this is what you need to analyze in the exam question. Which category, which type of calculation is this? Strong acid, like in this case, and therefore the application will be very simple. Is it a KW calculation? Is it a neutralization reaction? Is it a weak acid calculation? Or is a buffer calculation? So it's a whole topic. We can literally summarize it into 5 different calculations. If you think it this way, it will help you already getting started in the equation, okay? And now I'm going to go through, sorry, I'm going through super quickly, but I will look at now these key things, okay? Sorry, I know it's annoying to see all of the slides. Okay, first thing, weak acid calculation, of course, is the simplest one, but trust me that some of you will get it wrong if you don't think about moles ratio moles, okay? Very important. The most common mistakes that I see in such a simple question like this, but when instead of giving HCl, you have H2SO4 is forget the ratio, okay? That's why it's fundamental that, yeah, you make this clear statement, ratio. Always think about that, okay? Because this is a very easy mistake to make. So please make sure you always think about that. I don't want you to get this wrong ever. So think about ratio between H plus and the acid. Because pH is always the H plus, not the full acid, okay? This is, of course, valid also for the base calculations, okay? In fact, so this one I'm going to skip it for a moment, but pH of basic solution, okay? Just look at this question. Do you see already the challenge that I mentioned in the question before? Suddenly you have a BaOH2. The ratio between hydroxide and the whole base is not 1:1 anymore. So you're going to have to consider the ratio, okay? This is very important. And then, yeah, just to take a second to see how to calculate it in a simpler example. With a basic solution, we need to use KW. Again, this is the second type of calculation that I mentioned. Yeah, if you have a basic solution, you need to use KW. Okay, arrangement should be simple. You should be able to apply this right away because you know what? In the question, you're given KW. So that's already a hint like, maybe I should write the KW down because I know that I'm going to have to rearrange it at some point. Okay. In fact, why don't we start with this? So can you guys try this question? Yeah, if you're watching the recording, make sure you pause the video and play when you want the answer. Okay, so without too much explanation, the correct answer is a 13.2. Okay, very important that again, and here I want to highlight it so much. Yeah, it's the correct arrangement of KW and the most important thing, the ratio. So we have 0.16 for the concentration of the hydroxide ion, meaning that if we do the correct arrangement of KW, we get 13.2. Okay, very good. Okay, so for the basic calculations, so for the calculation of a basic solution, we can have a little bit more extensive question. And I want you to take a moment to go through this question together because now, very, very important, neutralization reactions. You must understand by reading the question that a chemical reaction is taking place. It's fundamental in this acid and base calculation. And you just have to understand it as you read the question, okay? And that's why I suggest you to, as a first step, so step 0 even, I call it here, you're looking at the chemical equation that is taking place, yeah? And in this case, very simple. It's a strong acid and strong base, okay? Calculate the pH of a resulting solution. Great. What is happening? Yeah. Think chemically. What is happening? Sometimes it's not even a chemical reaction because instead it's a dilution that is taking place. Okay. And in this case, you would know it because you read it from the question and you see, nothing is actually reacting together. So really, it's so important that you read it carefully, the question. Equation that it's taking place. And now you need to think about the basics. So acid, base makes a salt and water. Okay. Equation down can help with visualizing it. But then again, the logic that very often it's not easy to get is that a chemical reaction is take place, which means that they're going to cancel out, isn't it? There is going to be an excess of a reactant, okay? And this is what you have to find. So in amount of substance, this type of calculation would be finding the limiting reactant or find the maximum mass or the maximum amount of a product. Yeah, it follows the same. Of course, the wording is a bit different of the question, but again, it's just a chemical reaction taking place. When you have the value of both reactants, you know that, yeah, one will react, the other one is going to be in excess. So one is fully used up, the other one will be present in excess, which means that you needed to calculate the amount in excess. Okay? This is the first thing, and you must be able to interpret it from reading the question. Then, one very common thing that we can get wrong is moles concentration. If you're given volumes, you know Kw, right? I write it here. Kw is H plus concentration times OH minus concentration. Again, this bracket, visualize it. It's concentration. So if you have the moles, you're going to have to find the concentration. It may seem obvious, but it's a very easy thing to get wrong. Okay? So make sure you always clearly think about moles concentration. Okay? Because in fact, like in this case of a neutralization reaction, I'm looking now at the concentration of hydroxide ion. Notice that we're going to have to sum up the two volumes. It's not obvious, but if you visualize it, thinking, chemical reaction taking place, meaning that I'm mixing two solutions, all right, so the final solution would be in a bigger volume. It's not obvious, but we need to be in our mind this clear during the exam. Okay, and then we end up finding the pH. Of course, these neutralization reactions can go into different directions. In this case, we have a strong acid and strong base, meaning that we can either have a strong acid or a strong base calculation. Strong acid, just a clear pH. Strong base, we need to use Kw. But things get a lot more interesting when we have a neutralization reaction, but we have a base and a weak acid. And we're going to get into these examples right away. Okay, I suggested just this question maybe to try yourself later, but I just really wanted for you to have so clear the types of calculations that we're doing. Okay, and so I'm going to move on 1 second. Okay, this one, you will have access to all of these notes anyway, okay? So actually, I think I want to do one different thing, sorry, to change things around. Okay, so I'm just opening up the whiteboard because I want to make a little mind map of this type of calculations. And I know mind map normally it's not for this type of topics, but in this case, I think it's super useful. So I hope everybody can see the whiteboard now. Yeah. Okay. Okay, so we're looking at the whiteboard. Okay, perfect. Okay. Okay, we can all write it down. That's great. And okay, I want to do this mind. One second, am I recording at the moment? Yes, I am. So I want us to look at the mind map and build a mind map of this type of calculation, okay? Because this is really the kind of what is it called? Not the backprint. Well, your map of the type of calculations, okay? We said from a neutralization reaction, okay? Backbone, thanks. Neutralization reactions, yeah? We can have strong, and SH plus means strong, and SOH minus, yeah, means strong, of course. And we can have just a linear pH calculation or, a pH calculation, but through KW, okay? This is kind of the simplest, calculation. But things are more interesting if we have a weak acid and a strong base. Okay. I want you to take a moment to think about, okay? Again, here is in this case, if this is in excess or if this is in excess. What if the weak acid is in excess? Which type of calculation do we have? And what type of calculation do we have if is the weak base that it is in excess? If we have a strong base with excess weak acid, we're going to end up with a buffer calculation. And buffer calculation at the end is just a Ka calculation, thinking about the salt this time. If we have the base that is in excess, it's just a linear pH calculation through Kw. Okay? But this is why I want you to really learn to interpret the question, to understand what is happening chemically, and then think about, it will lead me to one type or another of calculation. Okay. And now, of course, we're going to see some examples of this calculation of H plus, like when it's a weak acid in excess that forms a buffer solution. Okay. But do you see how at the end we have just this type of calculations? Yeah. And through understanding the chemistry behind it, I am sure that it will really, really help with the application. I really want you to keep in mind what I just said about the type of calculation and understanding the chemical reaction that is taking place. I mean, obviously here on the slide, you have the hint that it's a buffer. And also in the question, you have a buffer solution. But really the goal is that you understand chemically what is happening, and you are able to identify the type of calculation that this will lead to. So I want you to take a moment to start by writing the chemical reaction and do just the overview, of the chemistry in the question without proceeding too much on the calculations. But I really need you to have the good habit of understanding chemically what is happening. So please pause the video and try to write down the equation, okay? And fully understand what is happening before you get into any numerical calculation. So one more time, the habit that I want you to build is how to approach the questions, okay? So sodium hydroxide, ethanoic acid, how am I going to understand chemistry with words? No. Equation. You can either do, of course, with the acid, you can always use it as HA, like to make it shorter, and that's totally okay. But this is the first step that I would do, no? Write down the equation to fully understand. HA and sodium hydroxide, what are we going to have? NaA plus water, okay? But if I know that it's a buffer solution that is formed, but just by understanding this, it will really help you thinking, oh, right, this must be in excess, which means that we have a weak acid in excess, a salt, all right, it's a buffer solution. Okay, now this was just the overview, and really I want you to approach the question in a slight different way. So all of the exam practice that we're going to do from now until the end of the hour, I really want you to approach the questions in this way. Okay, and we're going to get started right away. Okay, now really applying what we said. Yeah, we were going to get into some exam practice. Okay, and the goal is really to get confident with the approach to the question. Okay, before we get into complex calculation, I just want to do a few simple calculations, not calculations, sorry, but the simpler questions that tackle some foundation concepts. Okay, and we're going to get started right away with this one marker on the acid-base conjugate pairs. Okay, remember that most of the time you're going to be given the two acids reacting together. So you're going to have to figure out which one is behaving as an acid and as a base. The most important thing is that you always apply the basics. What is the basic here? The definition: Bronsted-Lowry acid, Bronsted-Lowry base, acid, proton donor, base, proton acceptor. Apply that to do the labels. Pause the video if you're watching the recording and play when you're ready for the solution. I know this concept of two acids reacting together, so one would behave as acid and one as a base, can be a bit confusing. And sometimes you have these questions even more difficult when you're asked to interpret the pKa instead, or the Ka. Okay, that's why I want to take a moment to actually think about that. Okay, and let's think for a moment now, and this will also help in the equations. When you're given a Ka value, it means we're talking about weak acids. Obvious, but not. So what I suggest you to do, sorry, my pen sometimes. Okay, what I suggest you to do is write down clearly, or just, the general Ka, because this always helps give a bit of visual to your explanation. Okay, because what does it mean, highest pKa? What is that? So P, remember, means negative logarithm. So pKa is the negative logarithm of Ka, first of all, because P always means negative logarithm, right? And there is nothing to learn here. You need to learn the logical pathway so that you can really think about this logical pathway again, okay? In fact, if the pKa is the negative logarithm of Ka, it means that the highest the value of Ka, the lowest the value of the pKa. It's the same as pH and H plus is the same relationship because negative logarithm. So what does this mean in terms of strength of the acid? The highest the Ka, it means that we have a greater dissociation of the acid. Yeah, because we have a greater value of the products, meaning that the highest the Ka, the highest the amount of H plus, which basically will tell us that it's stronger. Okay, that means stronger, kind of circulating, but yeah, which means that in this specific example, if we look at these pairs, because remember, the pairs are always, the same species with the exchange of H plus, the CH3 is acting as a base. So I'm going to label it base 1 because it's accepting the proton, which means that this is going to be the acid one, because if we look backwards, it's donating the proton. And this means that it's going to be the acid 2 because it's losing, so proton donor, and in the opposite direction is going to be the base. Okay, so if HCOH is an acid, it means it is a stronger acid, so it's going to have the lowest pKa. So the highest pKa would be for B1. Why? Because it's a weaker acid. And it's very logical. So again, nothing to memorize, just very important that you fully understand the meaning of the equilibrium constant. In this case, the acid dissociation constant. Okay. I hope that makes sense, and I hope this will help in the logical. Again, always be as clear as possible in your own explanation, okay? So that you really write things down like sketch things down just like I did to follow your logical path. Okay. And said that, I think this is, of course, a very important topic, but I would like to get into a couple of calculations. So the next question for you to try, and it's something that I haven't explained it clearly because it's not a really a chemical reaction, but still a fundamental calculation to be able to be confident in it. Of course, I've chosen this because it's not this like most linear type of calculation. So very important. I always want you to approach the questions by thinking, which type of calculation is this? Strong, weak, base, acid, buffer. Okay? Pause the video if you're watching the recording because when you play, I will be giving you the answer. Okay. Again, fundamental is the approach of the question. Okay, trust me on this. It will help you with the in the exam. So what do we have? Acid, Ka. Great. Let me write the Ka like super quickly just to have it visual. Again, ignore my pen and that today is just not on my side. Yeah. Okay, perfect. Knowing this, I need to, as I can see, I need to find the Ka, but I need to find the pKa. Great. What is the pKa? It's the negative logarithm of Ka. Super good. Now, what do I know? Concentration, and then know the pH. Oh, how do we get then the concentration of H plus? Okay, this is also very important calculation, and the logarithm property that you need to know that to revert the logarithm, you need to do the 10 to the power of minus of the pH. Okay. Good. So getting that, doing the correct arrangement for the Ka. One thing. When are you do, and I hope you identified by having the backbone of the question down and understanding there is not chemical reaction taking place. It's really just calculating the pH or the property of just one solution. It's a weak acid because nothing else is taking place. Now, it's extremely important that you remember the assumptions of the weak acid. Weak acid, we're considering. We're basically ignoring the dissociation of water and we're saying that these two values are exactly the same. Okay? Because these will help you arrange the equation in a very simple way. So H plus to the power of 2. Okay, very important to always think about this assumption. Again, you work out this assumption by thinking is a weak acid calculation. So, right, this is the assumption I have to make. Okay, otherwise, you logically know what is happening in this reaction. It's just an acid dissociation ratio 1:1 between the conjugate base and the H plus. So, you know, this arrangement is all logic that goes into it. Okay, super, super important. Okay, and I hope, guys, you all got 3.78 because this is the correct answer. And if you did, well done. If not, try again. If you get it wrong again, you need to send it to me for marking. I hope you're ready for the next question. Again, before you get into any number, any calculation, you must have clear what is happening chemically, if it's a chemical reaction, if it's just a dilution, what is going on. Use that approach to complete this 6 mark. Okay? 6 marks, 6 minutes. The time is ticking. If you're watching the recording, you might want to put a stopwatch on and otherwise play when you've done it because we will go through the solution. Okay, I hope that you understood, what is going on, okay? Because again, the most important thing you can do is understanding what type of reaction is taking place. So first of all, you're given Kw. So why don't you write Kw down? It can really help you, understanding what's going on and just visualizing it. And I think it's just a nice way to start right away exam questions. And then what do we have? We have sodium hydroxide. Sorry, my pen is really not helping today. Sodium hydroxide and H2SO4. there, so we know, oh, right, it's a neutralization reaction. The salt doesn't even matter what it's formed, but you just realize, it's a neutralization reaction, meaning these two are reacting together. So what do I have to do? I have to find the moles of both, what is in excess, and then this will tell me if it's a acid, a strong acid, because it's a strong acid, or a strong base calculation. Okay, and the step by step, I'm going to copy down what we should be doing. So first, we're going to calculate the moles of the acid. Okay, again, very, very important. I never want you to forget the ratio because it's a diprotic acid, H2SO4. Again, always when you think about the pH, you always need to think about that you're calculating H plus. Okay, then. That's why actually the equation, to be honest, it would be important to write it fully because then you realize, oh, right, I actually need to balance it with the, a 2. So we see it's 2-to-1 ratio, okay? But anyway, okay. Next, we calculate the moles of the hydroxide. Doesn't matter which order you're doing, as long as at the end you're getting to the moles and the excess, of course. This is super, super important. So please check your steps. We have an excess moles. Very important that you understand, how to calculate what's in excess. Okay. Then again, 2 solutions are mixed, which means that you're going to need to get the total volume. Very, very important, the total volume. And now, of course, you have the total volume. You can find the concentration, but I like to do it really clearly step by step because like this, you really understand what's going on. And then what do you do after? That's it. You find the H plus and you will be able to find the pH. So who got a slightly different value than this? I invite you to look back and see what went wrong. Was it a rounding? Was it finding the excess or anything else? This is the next question. Again, I don't want you to take longer than 5 minutes, so give it a go. Again, the most important thing of today is that you learn the type of calculation and the approach for the acid and base calculations, okay? 5 marks, 5 minutes, get started, play the video when you want to look at the solution. I'm going to walk you through the answer. Again, wordy. Before you get into any number, make sure that you understand what is going on. So for this purpose, you know what I would do? The step 0 that it's very important to do, which is write down the equation. Can be ionic equation, can be full equation, whatever you want, okay? As long as you have something visual to understand what's going on, okay? So as we know, we're mixing weak acid. We're mixing a weak acid with a strong base. So what do we need to do? We know that the calculation can go in 2 different directions, and that is weak acid is in excess, or weak acid strong base buffer, or the strong base is in excess, Kw. Do you see that there is no Kw in the question? It's unlikely to be a strong base, okay? First hint. Then, anyway, the steps to do. We're going to have to calculate the moles of both because, of course, guys, what do we need to do is, we need to figure out what's in excess, okay? Because, again, this is what the term means. Is what the term is. Check the moles. If you got them right, moles of hydroxide, moles of the acid, these are the values. Do you see how the moles of the weak acids are in excess? Great. And we have the moles of the salt. Of course, very important. Here it comes from the understanding of the buffer, that the buffer is formed because the base gives us the salt. And as we know, weak acid with salt, it's a buffer solution. It's as simple as that. You just need to make sure you understand that, okay? Then, of course, we know we're mixing 2 solutions. So guess what? We're going to have to find the total volume of the solutions because of course, we need to get to the calculation. Now, this time I didn't write down the Ka yet, but if you write it straight away, then you know that you're going to have to find the concentrations, okay? This is because we can use the Ka expression to rearrange. Now, I really want you to notice one thing. Buffer calculations, they are almost the same as the weak acids calculations. The only difference is that we do not do the assumption that H plus and A minus, or in this case, X minus, is the same, because they're not, because the conjugate base comes from the salt. Okay? It's as simple as that. I hope you check your values in the meantime, because then we should get this pH. So I want you to, if you didn't get it right, I want you to take a moment to find the mistake. I know I think it's super easy to miss out that it's a buffer, but if you fully understand that when you start your calculation and you have a weak acid in excess and a strong base, you have a buffer, okay? And then again, by visualizing clearly that you have this chemical reaction, do you see how that it's different from the chemical reaction that we saw earlier, that is HX, that simply dissociates into H plus and X minus? And of course, this we can make the assumption that there's like nothing. My pen today is just not helping. Anyway, you can make the assumption that these two are the same. Yeah, but do you see how they're the same? Because nothing else is being added, so it's 1-to-1 ratio. But please take a moment to see the differences between these two reactions. For today, I concluded here because it's a lot. And come on, how I explain it, it sounds like the simplest thing, but I know it's not. We looked at, to take a break from calculations, we looked at one example. Oops. We looked at the concept of the conjugate acid, conjugate base, and this acid-base pair, and understanding the Ka, yeah, and how this relates to the strength of the acid, a fundamental concept, okay? I highly suggest you to practice it, even just by, looking at a conjugate acid-base system and just really thinking about the Ka and the pKa, so really thinking about this relationship. Then we looked at the type of calculations that I think they're really challenging, the neutralization reactions. We did one question on just weak acids, just because I wanted you to realize how weak acids calculation, they're very similar, but of course different than the buffers. And the very difficult ones of buffers, it's not the one that they clearly tell you, oh, this is a buffer, oh, weak acid and the salt. No, is when you have a neutralization reaction. Neutralization reaction, you must have clear, and we saw two examples here of neutralization reactions. One where we had a strong acid and a strong base. Again, realizing, oh, what is in excess? And this is what determines the pH. Yeah, same neutralization reaction. What is in excess determines the pH. Again, you should really click right away, weak acid in excess and strong base, buffer. And having the chemical equation down, you would realize, all right, we cannot make the assumption that these are the same, because they're not, because the conjugate base comes this time from the salt. The next step will be complete the booklet that I will upload on the classroom, because this will help you applying this key concept and really in a bit more ordered way to go through the key concept of this acid and base and buffers topic. And then it would be to fully process what I've been explaining today, which is a kind of a more generalized approach of calculations, but I hope that this will help you in the exam questions, so to get confident with starting and understanding advanced calculation like this one. Okay, so thank you for joining. You will have more instructions in the classroom.